Alright, today we're going to cover our last unit in this, or our last section in this unit, 9.8, which is applications and modeling. So I gave you the sheet with all the problems on it. So if you haven't already, I want you to go through those problems, try to do them the best you can, and then unpause the video and we'll go through and check your work on each problem. Okay. So for the first problem, from a point 100 feet in front of a public library, the angles of elevation of the base of the flagpole and the top of the flagpole are 28 degrees and 39 degrees 45 minutes respectively. The flagpole is mounted on the front of the library's roof. Find the height of the pole. So a couple things I want to refresh your memory on when we're doing word problems. Make sure you draw a picture. Make sure you answer your question in a sentence. So first I drew the picture. We need the picture to make sure we understand the problem. So I have two right triangles, one large right triangle and one smaller right triangle inside of it. H here represents the height of the library. X represents the height of the flagpole on top of the front of the library. I didn't draw the library, but that would be off to the right here. So then this is my diagram. I know the tangent of 28 degrees is h over 100, so if I use my calculator, make sure my calculator's in degrees, I get h is approximately 53.171 feet. Remember, always round to at least 3 decimal places or carry at least 3 decimal places with you, unless it's specified otherwise. Also, don't round until the very end. So then I have the tangent of 39.75 degrees is h plus x over 100, so h plus x is 83.169. So x is 83.169 minus 53.171, which is 29.998 feet. So then the height of the flagpole is 29.998 feet, or approximately 30 feet. Alright, for number 2, an engineer erects a 75-foot vertical cellular phone tower. Find the angle of depression from the top of the tower to the person standing on the ground 95 feet from the base of the tower. So we're assuming the tower is straight vertical, so it forms a right angle with the ground. Here is the angle of depression, which is also the angle of elevation from the person, because these would be alternate interior angles, assuming that the horizon and the ground are parallel to each other. So I draw this figure. I know that the tangent of theta is 75 over 95, so theta is the tangent versus 75 over 95. So theta is approximately 38.290 degrees. Answer my question in a sentence. The angle of depression from the top of the tower to the person 95 feet away is 38.29 degrees. Here's an example of where it didn't specify, and on a test or a quiz I will try to, but most of the time if we're finding an angle, we want our answer in degrees as opposed to radians. If it's dealing with a word problem like this, because it's a lot easier for us to understand what is 38 degrees approximately. Okay, so here two fire towers are 30 kilometers apart, Tower A being due west of Tower B. A fire is spotted from the towers, and the bearings from A and B are east 14 degrees north and west 34 degrees north respectively. Find the distance D of the fire from the line segment AB. Okay, so this is what your picture should look like, or something along these lines. Here's A, here's B, here's the fire. This is my east 14 degrees north. This is my west 34 degrees north. This is a distance of 30. I said that this was 30 minus x, so this is x. This is D that I'm trying to find. So now here we're going to end up with a system of equations. So I first said tangent of 14 is D over 30 minus x, and at the same time I know tangent of 34 is D over x. So if I solve both of these equations for D, I end up with 30 minus x, the quantity 30 minus x times the tangent of 14 equals D, and x times tangent of 34 equals D. So now I set those equations equal to each other because they both equal D. So if I distribute tangent of 14, I get 30 tangent of 14 minus x tangent of 14 equals x tangent of 34. Solve this equation for x. So I group the x's together on one side. So I added over the x tangent of 14, factor out x, and divide by tan 34 plus tan 14. So I end up with x equals 30 tangent of 14 over tangent of 34 plus tangent of 14. I type this into my calculator, making sure I'm in degrees. Hopefully I typed it in correctly, and I got x is approximately 8.096 kilometers. Now I went back up here to this equation, and I plugged in x to solve for D. So 8.096 times the tangent of 34 equals D. so D is approximately 5.461 kilometers. Now I answer in a sentence. The distance from line segment AB to the fire is 5.61 kilometers. Alright, for number 4, an airplane flying at 600 miles per hour has a bearing of north 52 degrees east after flying for 1.5 hours. How far north and how far east has the plane traveled from its point of departure? Well, first I want to convert 600 miles per hour into miles because the answers that I'm looking for are distances. And so I want my answers in miles. Therefore, when I draw this right triangle, and I know that looks really sloppy, but that's what it is, X and Y need to be in terms of miles. I could keep them in miles per hour, then I'm going to have to convert them to miles later. Actually, it doesn't make a huge difference, but it's just nicer to be working in the units that you want your answer in. So the first thing I did after I drew my triangle, there's my little airplane, there's 52 degrees. I'm trying to find X and Y. I multiply 600 times 1.5 to get 900 miles. So I know that I've actually traveled 900 miles in this direction of north 52 degrees east. So now I just set up two separate trig equations, one to solve for X and one to solve for Y. So I know the sine of 52 equals X over 900, so X is approximately 709.210 miles. And I know the cosine of 52 equals Y over 900, so Y is approximately 554.095 miles. So then I answer my question in a sentence. The plane has traveled 709.21 miles east and 554.095 miles north. Okay, so this one is definitely the most amount of work and the most complicated diagram as well. So you leave the entrance to a system of hiking trails and hike 2.3 miles on a bearing of south 31 degrees west. Then the trail turns 90 degrees clockwise and you hike 3.5 miles on a bearing of north 59 degrees west. How far are you from the entrance to the trail system? What is your bearing from the entrance to the trail system? Okay, sorry about the typo there in system. So this is my diagram. Here's where you start. So you're hiking 2.3 miles. So the green segment is the 2.3 miles of the initial hike at an angle of south 31 degrees west. So this angle right here is south 31 degrees west. Then you turn 90 degrees. So from here I turned 90 degrees clockwise. Now what does that mean? Well, remember I'm facing kind of what you would say southwest here. So I'm facing southwest, so then I'm going to turn 90 degrees. And then you start hiking 3.5 miles at a bearing of north 59 degrees west. And so then this segment is your 3.5 mile hike. So this point right here, this is where you are. Now you're trying to find the distance back to the start. You're also trying to find the bearing from the start. So if you were at the start, what would be the bearing that somebody would take to get to you? So now you can see that I made a bunch of right triangles out of this. And then from there I labeled a bunch of variables. So if I connect this segment straight up, now I created kind of a box here. And I know this angle is also going to be 31 degrees because of alternate interior angles. And I can find this distance y, what I called y. You could have used different variables. And I can also find this distance w. So I said the cosine of 31 equals y over 2.3, so y is 1.971 miles. Sine of 31 equals w over 2.3, so w is 1.185 miles. Now I want to do that same kind of thing over here and create a right triangle from the 3.5 mile hike. So I called this z and I called this q. So I said sine of 59 equals z over 3.5, so z is 3.000 miles. The cosine of 59 is q over 3.5, so q is 1.803 miles. Hopefully I typed all of this into my calculator correctly. Now the reason why I wanted to find all of that information is I actually want to find p and r so that I have this right triangle so that I can solve for x and this angle theta. So I know p is y minus q, and so that's 1.971 minus 1.803, which is 0.168. And so to come back up to the diagram, this whole distance right here, this is also y. So I know y is p plus q, so that's why p was y minus q. And then using the Pythagorean theorem, I know p squared plus r squared is x squared. To find r, I know that's z plus w. So again, if I look here, this is z, this is W, that's the same as R. So I found R is 4.185. So then, using the Pythagorean theorem, I can find x, p squared plus r squared is x squared. So that's how I get x is 4.188 miles. So that is my distance to the entrance of the trail system. And then to find theta, I can do the tan inverse of 0.168 over 4.185, and I get 2.299 degrees. So you are 4.188 miles from the entrance at a bearing of west, 2.299 degrees south from the entrance to the trail system. You could do the complement of this as well. So if you did the complement of this angle, it's going to be like 87 point something degrees. That would be south 87 point something degrees west. So remember, when you're doing bearings, there are many ways in which you can write the same angle. Since this was the angle I found, I chose just to use that one in my answer. There are other ways in which you could have done this problem, so as long as you got the correct distance and the correct bearing, within a few decimal places, depending on how you rounded, you could have done this problem correctly. Okay, so this one we're going to go through a little bit quicker. We've done problems like this already. We've done one in an earlier unit that was almost the exact same as this. So here's my diagram. This is where I start at an angle of elevation. I see the top of the mountain. I drive 17 miles at an angle of elevation of 9 degrees now. I see the top of the mountain. This is the distance I'm calling x. So I set up a system of equations. Tangent of 9 equals h over x, so h is x times tangent of 9. Tangent of 2.5 is h over 17 plus x, so h is 17 plus x, the quantity 17 plus x times tangent of 2.5. Now I set these two equations equal to each other, and I solve for x, so that's the work I can see down here. This is once I set them equal to each other. I solved this for x, typed this into my calculator, got approximately 6.470 miles. So then I know h is 6.47 times tangent of 9, which is 1.025 miles. So the height of the mountain is 1.025 miles. Alright, so we want to make sure we understand angle of elevation, angle of depression, and understand bearing.